All right, video 3, and then we are finished for the night. At least Miss Vargas is. I have got a new compound. I'm not exactly sure what this is. It is not binary. Remember we did not learn how to name non-binary molecular compounds. So where I'll start instead is figuring out how many atoms I have in my compound, which is going to be the central atom, and finding the number of valence electrons. So I have one carbon here. I've got 2 hydrogens and a sulfur. So I've got 4 atoms altogether. I know that carbon has 4 valence electrons. Each hydrogen has 1, so there are 2 valence electrons contributed by the hydrogens. And then sulfur has 6. It's just like oxygen. So altogether, I have 12 valence electrons to noodle around with. If you don't have your periodic table burned into your brain, let's see which of these elements is closer to the center of the periodic table, and we will put that in the center. I know it's not going to be hydrogen, because hydrogen is over here. I've got carbon, and I've got sulfur, right? So carbon is closer to the center. Carbon is going to be the central atom. So carbon is going to be the central atom. It is attached to 3 other atoms. So I'm just going to start this way. I know the carbon is bonded to each of the hydrogens, and I know that it's also going to be bonded to the sulfur. Okay, I know I'm not done, but just to get a start, there are only 3 connections between carbon and other atoms, because there are only 3 other atoms. So I've placed 6, and I have 6 left. I know that hydrogen is good, right? Hydrogen wants 2. Hydrogen currently has 2. All right, so hydrogen, I don't need to pay attention to it anymore. If I look at carbon, however, I see that carbon right now has 6, right? It needs 2 more. Before I start adding electrons, I am going to kind of talk about carbon and sulfur. So carbon needs another, pair of electrons, right? It needs 2 more. And sulfur right now only has 2. I have 6 left to place. If you recall what we talked about in terms of patterns, we said that carbon likes to have 4 valence electrons, 4 bonds. Nitrogen and phosphorus, which is underneath nitrogen, likes to have 3 bonds and a lone pair. And that oxygen, and sulfur is below oxygen, so this applies to oxygen as well, likes to have 2 bonds and 2 lone pairs. Okay, you'll notice that something's kind of different than the previous formulas we've drawn out. All right, sulfur, I'll just draw this as sulfur too, because it behaves just like oxygen in terms of bonding. Sulfur doesn't have anything else to bond to, right? It's on the end. There is nothing over here for sulfur to attach itself to. There's nothing there. This brings up the concept of multiple bonds. Okay, so let's see, I'm not quite sure where they are I think they're backwards. Okay. In covalent bonds, you can have a single bond, double bonds, or triple bonds. And so what we're running into on our Lewis structure right now is that there is a multiple bond in our structure. Okay, so let's take a little side trip and talk about what that means. A double bond is a bond that contains 4 electrons. Okay, and they're drawn like this. If you're doing the structural formulas, you'd use a double dash. If you are doing dot structures, you're going to be using 4 electrons. Okay. So a double bond contains 4 electrons. A triple bond contains 6 electrons. Okay, so each of these lines represents a bond, and each of those lines contains 2 valence electrons. Regardless, if I have a single bond, 2 valence electrons. If I have a double bond, there are 2 valence electrons in each. Okay, 4 altogether. You can tell it's getting late because my handwriting is getting almost illegible. And then finally, for a triple bond, each of them has 2 valence electrons. Okay, for a total of 6. Right? So what we are running into here is we have a multiple bond. Now, carbon likes to form 4 bonds, but it doesn't have to be 4 single bonds. It could be 2 double bonds. It could be a single and a triple. Any iteration that gets us to 4 bonds, okay, is fine. Similarly, nitrogen can have 3 single bonds and a lone pair, or it can have a double bond and a single bond and a lone pair, or it can have a triple bond and a lone pair. Sulfur or oxygen, I'll do sulfur in this case because we've got sulfur in our compound, can have 2 single bonds and 2 lone pairs, or it can have a double bond and 2 lone pairs. So, because sulfur is a terminal or terminus, I don't know, I don't take Latin, maybe terminus is a better way to describe that. I know for sure that sulfur will have 2 lone pairs. Since it's not bonding to anything else, it has to have a double bond. And when I do that, when I draw a double bond between sulfur and carbon, it also takes care of the carbon. Carbon now has 8 as well. Oops, that's not what I wanted to do. Carbon now has an octet of electrons. Okay. So carbon has 2, 4, 6, 8. Each hydrogen has 2, which is good. And the sulfur has 2, 4 in the double bond, 6, 8 with the lone pairs. Okay. So let me, we'll do one more with a multiple bond. I'm gonna do it on the next page. I don't have anything set up, but let me think of one. Let's do this one. Oops, let me make it darker so it's easier to see. HCN. Okay, I've got 3 atoms altogether. I know that if I have carbon, it's going to be the central atom. Okay, actually what I should do first, I was just going to skip over that. Figure out how many valence electrons I have to work with. I have a hydrogen with 1, carbon with 4, nitrogen with 5. So altogether I've got 10 valence electrons to play around with. I know carbon's going to be in the middle and hydrogen's going to be on one side, nitrogen's going to be on the other. Now, I've taken care of 4 valence electrons. I have 6 left. I know that hydrogen is good. So that side, so hydrogen's good, which means that that bond for carbon is done. I know that carbon likes to form 4 bonds. I know that nitrogen likes to form 3 bonds and have a lone pair. So how can I take these 6 electrons here and accomplish all of these things? And you can see why I keep kind of describing it as a puzzle. It's exactly what's happening here. Well, I know nitrogen is going to want a lone pair. So there's 2. I'm now down to 4. Really, carbon right now has two bonds. It wants 4. I'm going to make this a triple. When I make that a triple, I also it also works for nitrogen, right? So now carbon has a single bond with 2 electrons and a triple bond with 6 electrons. There's 8. Nitrogen also has 8 because it's got a triple bond, 2, 4, 6, and then that lone pair is 8. So you'll get used to structures where all of a sudden it feels like you have like not enough electrons or too many electrons or something's a little weird. If that happens to you, think I might have a multiple bond here. Maybe there's a multiple bond here. See if you can satisfy all these kind of different aspects of bonding. The octet, right? The fact that each atom gets an octet around it, unless it's hydrogen, helium, or boron with 6. Okay, that carbon likes to carbon and silicon like to form 4 bonds. Nitrogen, phosphorus, and arsenic even like to form 3 bonds with a lone pair. And that oxygen and sulfur and selenium like to form 2 bonds with 2 lone pairs. And that hydrogen likes to form 1 bond, and the halogens like to form a bond and have 3 lone pairs. So if you can kind of keep all of those things in mind as you're working through Lewis structures and dot structures, it'll be tremendously helpful for you to get to the right answer. All right, my friends, that's it for me for tonight. It's 10 after 11. I'm gonna go do night-night, and we'll see each other tomorrow in class. Bye.